All right, so we've talked about all of the easily transferable functional group manipulations that we can do with these different carboxylic acid derivatives. And now what we should do is try and fill in this little hierarchy chart. So carboxylic acid derivative hierarchy. So what's the highest in energy? Next highest, there's 2 blanks in this spot and 1 blank on the bottom spot. So this is the most stable to the least stable. And then additionally, how do we go between the different types of derivatives? How do we go from whatever is least stable to this one? How about to that one? Et cetera, et cetera. So this is something you can fill out to kind of put all the concepts in this chapter all together. This board kind of is not, it's kind of too small to do a full analysis here. But work on that right now. Pause it. You did it. Should take you a little while because you're putting in the conditions to go from one transfer to another, et cetera, et cetera. So it should take you a little while. But once you're done, it should look something like this. We have the acid chloride that's most reactive. So what if we want to go from an amide to an anhydride? Oh, well, if we want to do that, we have to get from the amide to the carboxylic acid. The only way we can go higher in energy from the carboxylic acid is using our specialty reagent, thionyl chloride. That would take us to the acid chloride. Then we would react that with a carboxylate, which would get us to the anhydride. So essentially, this is a roadmap for, we have this derivative, we want this derivative, how do we get there? Below that is a table from your textbook, summary of all the different reagents and which directions you can go. You can see it's table 22.5, but it's kind of a table version of what we just filled in here. But hopefully you thought it through. I think it's a really important exercise for you to try to think through, how do we get from this one to this one? How do we get from this one to this one? Et cetera, et cetera. So, yeah.